Hi, thank you so much for joining me on the Math Social. Today we are going to talk about the product rule when it comes to exponents. Let's get started. I bet you've seen a number that looks like this. 4 squared is equal to 4 times 4. So this large number here, the 4, that is called our base. And then this smaller number up there, that 2, that is called our exponent. So that means we take our base and we multiply it to itself this many times. So 4 squared is going to be the same as 4 times 4, which would give us 16. Now, if we have a number here and we decide to multiply it by another number with an exponent, what you really do is add the exponents, and let me show you why. So when we have a number like this, that already implies multiplication. Remember, we take that number and we multiply it to itself this many times. I'm just going to bring this multiplication sign and put it right here. And then what this means is 4 times 4 times 4. Again, we take this base and we multiply it to itself this many times. So I'm going to write 4 times 4 times 4. So now what we're going to do, just to simplify it, is we are going to count how many 4s that we're multiplying to itself. 1, 2, 3, 4, 5. So another way of writing this would be 4 to the 5th power, okay? So as you can see, when you have two numbers that are the same base, you really keep that base and you add the exponents. 2 plus 3, or 2 plus 3, is going to give us a total of 5. So we usually write the answer 4 to the 5th power. Now, we could actually find out what would that answer be. What is 4 times 4 times 4 times 4 times 4? It's going to be a very large number. Let me see what it is really quick. When you enter it into your calculator, you're going to press 4, and then you might see this little arrow button on your calculator. It looks like this. You would press that, and that means to the power of, and then I'm going to type a 5 in, and my answer is 1024. But a lot of times you could just write your answer like this. Let's do another one. For this example, we would have 3 to the 3rd power, or 3 cubed, and then we're multiplying that by 3 to the 4th power. So the first thing I want you to recognize is that our base is 3 in both of these examples, okay? So I'm going to keep that a 3. And then the next thing that you do is you add the exponents. We have 3 here, we have 4 here, and that would give us a total of 7. Remember, 3 to the 3rd power, or 3 cubed, is the same as writing 3 times 3 times 3, and then 3 to the 4th power is the same as writing 3 times 3 times 3 times 3, which would give us a total of 7 3s. Now, just like last time, if you want to find out what 3 to the 7th power is, I'm going to type a 3 into my calculator. Then I'm going to press that little arrow button that looks like that. That means to the power of. And then I'm going to type in 7 and press enter. And I get 2,187. But this is also the simplified answer in exponent form. Let's try another one. In this example, the first thing I want you to notice is that we have two different bases. We have a base of 7, and then we have a base of x. And x is an unknown, so we don't really know what that base is. So we can't combine these like we did in the other two examples because they're not the same base. So the way that I'm going to simplify this is just kind of rewriting it. 7 to the 5th, and then x squared. Okay? You always want to write the number out in front of the variable. It's called a coefficient. Okay? Another way of writing this same answer would be finding out what 7 to the 5th power is. So 7 to the power of 5 is 16,807. So I can just show you what this looks like. And then I don't know what x is, so I'm just going to rewrite that x squared. This is probably the best answer that is in the exponent form. And then if you were asked to find another version of that answer, this would mean the exact same thing. So to sum up, when you have the same bases like we did in the first two problems, you keep the base and you add the exponents. When you have two different bases, you just write them separately and then you keep the exponents that were by them beside them in your answer. Let's do another example. For this example, you will notice that we have two different bases. We have a 4 and we have a 3. So if we wanted to write this in exponent form, I would just write 4 cubed times 3 squared. We would kind of need to keep that multiplication symbol there, or we could put parentheses around both of these, which implies multiplication. But what you would probably want to do in this example is find out what the actual answer is, okay? So I would take my calculator and I would figure out 4 times 4 times 4, or 4 to the 3rd power. So 4 to the 3rd power is 64. And then I would multiply that by whatever 3 squared is. And 3 times 3 is 9. So 3 squared is 9. And then I would figure out what is 64 times 9, and that is 576. So when you have two numbers here instead of a variable, I would probably figure out what the full answer is instead of writing it like this, but this is certainly a way to do it. Let's keep going. Here is our next example. We have 7 squared x to the 4th power times 7 to the 8th power x squared. So what I want you to notice is we are dealing with 7s as bases, and then we are dealing with x's as bases. If I decided to insert a multiplication symbol in between these right here, that would not change my answer, because when these are right beside each other, that means multiplication. So since everything's being multiplied by each other, we are going to combine the things that have the same bases. So I see a 7 here and a 7 here. And then if you have the same bases, remember from the first couple problems, you get to add the exponents. So we have an exponent of 2 and we have an exponent of 8. 2 plus 8 is 10. So I am going to write 7 to the 10th power. Okay? Then we have x to the 4th and x squared. So I am going to write x to the 4 plus 2 is 6. So our final answer would be 7 to the 10th power, x to the 6th power. So remember, when your bases are the same, you just get to add the exponents, as long as this is a multiplication problem, okay? Let's do another one. Here is our next problem. I have 4x to the 3rd power y times 4 to the 6th power x cubed, or to the 3rd power y. So I want you to notice that we have 4's as bases, we have x's as bases, and we have y's as bases. And we are just going to combine the things that have the same bases. So right here, this 4, if you notice there's not an exponent up here, that means there's just one 4. And writing a little 1 up here, that would mean the exact same thing as this. So whenever you see a number just by itself without an exponent, that just means 1 4. So when we add the exponents, I don't want you to forget that there's a secret 1 up here. So we have 4 to the 1st power, which is just 4, and we're going to add the 6 to it because that is the exponent on the other 4. So 1 plus 6 is 7, so our answer is going to be 4 to the 7th power. And then we have 3 as our exponent on this x, and we also have another 3 on that x. So 3 plus 3 is 6, so I'm going to write x to the 6th. And then just the same as the 4, this is like there's a little 1 up here, but you don't necessarily have to write it if it's a 1. So we're going to add 1 plus oh, this is going to be another 1. So I'm going to write y squared because 1 plus 1 is 2. Another thing, when you're writing the answer, I know I told you you always want to have the number out in front. That is called a coefficient. And then when you write your variables or your letters, I would say to always do them in alphabetical order. So x comes before y, and that's why I wrote it in that particular order. Let's just do 2 more examples. Here is our next example. We have 2x to the 4th power y times 3 squared xy to the 5th power. So we have some x's that are similar and some y's that are similar. But if you notice here, the 2 and the 3 squared, those don't have the same basis, so I am not going to combine them. For now, I am just going to rewrite this 2, and I'm going to remember it's being multiplied by this 3 squared, and then I'm going to look at our variables. So I have an x here with 4, and I have an x here with 1. So I'm going to add 4 and 1 to make 5. So I'm going to write x to the 5th power. And then I have 1 y right here, and I have 5 y's right there. So I'm going to have a total of 6 y's. Okay, I just want to simplify this a little bit. So if you remember, 3 squared means 3 times 3, which is 9. So essentially, I have 2 times 9, and then I have my x to the 5th, y to my 6th. I'm just going to simplify this all the way because it's not a huge number, so it makes it pretty easy. 2 times 9 is 18, and then I have my x to the 5th, y to the 6th, and that would be the best way to write your answer. Usually, especially when you have smaller numbers, you might as well just multiply them out and write that answer in your final answer. Okay, let's just do one more problem. Here is our last problem for today. We have 8w x to the 4th power times x to the 3rd power y. So I want you to look at this, and we actually only have one thing that we can combine because we only have one similar base. The base of x shows up in both parts. So we have our 8 here, and we're not going to be able to combine our 8 with anything because there's not another number out there. So I'm just going to rewrite it, okay? Then I have my w. Remember, that is to the power of 1, but I don't see any other w's. So I'm just going to rewrite that. And as I'm doing this, I'm just making sure I'm going in alphabetical order, okay? The next thing I'm going to write is my x. I have 4 x's here and 3 x's there. And when you are multiplying, you add the exponents. So 4 plus 3 is 7. And then I don't have a y here, but I do have a y there. So I'm just going to rewrite that. Okay, just remember these both have an exponent of 1, but when you do have the exponent of 1, you don't really need to write it because there's just one of them there. And this is our final answer. Okay, my next video about the product rule of exponents, I'm going to include some negatives. It just gets a little tricky, so I didn't want to include all of that learning in just one video. I hope this made sense. If it did, don't forget to give me a thumbs up and please subscribe. Bye!